Hey, what's going on, guys? You see my previous video, I got the last one. I couldn't able to complete the last question, so I felt very bad about that, and I'm making this to solve that question. Making this video to solve that question. If you see this question, it's a little bit complicating question, but I'm gonna do it. The ninth question. Choose the inverse method to solve the following system of equations. So let's do the question first as fast as possible. X plus y is plus c is equal to 5, and the second one is x plus 2y plus 3z 4, and 2x plus y plus 2c equal 1. So this is our question. So the question is asking, use the inverse method to solve the following system of equations. So inverse method mean I don't know whether you know it or not. It's Gauss-Jordan method. Like um, if you switch the Gauss-Jordan from left to right to left, you will get the inverse answer. So I will show you one by one. So first, let's take the matrix form of these equations. So 1 1 1 5. So I'm going to directly write the Gauss Jordan right here too. So it's going to be 1 0 0 5 and 1 2 3 0 1 0 minus 4. Oh, it's not minus 4, it's 4. It's 4 and it's 4, and the next one is 2 1 2 0 0 1, and this is 1. So our goal is to bring this pattern, Gauss-Jordan pattern, to the right side. So if we bring that, this answer also will change and bring the inverse answer of this question. So that's what our main purpose of this question. Let's do it one by one. So I would like to start it from the bottom. So let's go to the first row, first column, that row. So I'm going to begin with that. 1 1 1 1 0 0 5 1 2 3 0 1 0 4, and the last one I have to make this one 0. So to do that, I have to multiply the first equation by -2 and add it to the third equation. So it's going to be -2 r2 plus r1 plus r3. It's going to give us 0, and -2 plus 1 is going to be -1, and -2 plus -2 is going to be 0. So the bottom one is going to be -2. -2 plus 0 is -2. 0 plus 0 is 0, and 0 plus 1 is going to be 1, and -2 times 5 is going to be -10. -10 plus 1 is going to be -9, and this is our bottom one. So I'm moving to the second row, first column. So second row, first column, if I have to make that one 0. So to do that, I have to multiply the first equation by -1 and add it to the second equation. So let's do it. 1 1 1 1 0 0 5, and I have to multiply the first equation by -1 and add it to the second equation. So which is going to give me 0. -1 plus 2 is going to be 1, and -1 plus 3 is going to be 2, and here if I multiply the -1 and 1 and then 0, which is going to give me -5 plus 4 is going to be -1, and the third one is going to be 0. When I see the negative over here, I would like to change it into positive, so it will make our life easier. So I'm going to change it to positive. So it's going to be 0 1 0 and 2 0 -1, and if it's -9, it's going to be +9. So let's move to the next one. So we have achieved the Gauss Jordan pattern for the first column. So now we have to move to the second column and change it to in Gauss Jordan method. So let's do the first row, second column. 1. I have to make this one 0. To do that, I can multiply the second or third equation by negative and add it to the first one. So I'm gonna multiply the second equation by negative and add it to the first one. So minus R2 plus R1, which is gonna give me is 1 0, and negative 2 plus 1 is gonna be negative 1, and here negative 1 is going to be positive 1, positive 1 plus positive 1 is going to be positive 2, and negative 1 plus 0 is going to be negative 1, and 0 plus 0 is 0, 0 plus 0 is 0, and negative 1 is positive 1, positive 1 plus 5 is 6. And the second row I'm going to copy as it is, and the third row is going to be 0 1 0 2 0 minus 1. So here's a trick. So since the third row, if you look at the third row, it's exactly look as the the second column of the Gauss Jordan pattern. So what I'm going to do is, instead of changing the second column into the Gauss Jordan pattern, I'm going to just swap this third column into third row into second row. So therefore we will reduce our work and make it work easier. So I'm going to swap it. 1 0 minus 1, 2 minus 1, 0 6 0 1 0 2 0 minus 1 and 9, and here 0 1 2 minus 1 1 0 is minus 1, right? So since we have this one right here, we have almost reached the pattern of Gauss Jordan in the second row, but we have to get this Gauss Jordan pattern for the third row, second column. So to do that, I have to multiply the second equation by negative 1 and add it to the third one. 1 0 minus 1 and 2 minus 1 0 6 0 1 0 2 0 minus 1 9, and the third one I have to multiply the second equation by negative and add it to the third one, so which is gonna give me what? 0 0 2, negative 2 plus negative 1 is going to be negative 3, and 0 plus 1 is going to be 1, and negative 1 is going to be positive 1, positive 1 plus 0 is going to be positive 1, and negative to negative 9 plus minus 1, negative 9 plus minus 1 is positive 10. So positive 10 we have got for the third one. So since we have achieved the Gauss Jordan pattern for the second column, we are moving to the third column right now. So to make the third column into 0, what I can do is I can divide the third equation by 2 and add it to the first equation. So if I do that, I will get a 0 for the third column. So let's do it. So it's going to be half R3 plus R1, which is going to give me 1 0 0, 1 0 0, half R3 minus 3 by 2 plus 2 is gonna be 1 by 2, 1 by 2, and 1 over 2 minus 1 is gonna be minus 1 over 2, and half plus 0 is half, and half R3 is going to be minus 5 plus 6 is positive 1, and we have achieved the Gauss Jordan pattern for the first one. Let's do the second one. Second one is already in Gauss Jordan pattern, 2 0 minus 1 9, and the third one 0 0 it's 2. So simply I can divide it by 2 to make it into Gauss Jordan pattern. So if I divide that, it's going to be 0, 0, 1 minus 3 by 2, 1 over 2, 1 over 2 minus 5. Let's check our answer here. 1, 9 minus 5. We got the answer. This time we are right. This time we are right. So last time I messed up. This time I got it right. So this is our A inverse and XY Z values. I hope you guys get it, and I would like to explain this once again to the other question. In the system of equation Ax is equal to B, the coefficient of matrix A is an invertible matrix. Find the number of solution of system. If A is invertible, it means a to the power of x multiplied by a inverse should be equal to b to the multiplied by a to the negative 1, right? So it seems a times a, we can put these two together. A times a to the power of minus 1 x is equal to b to the b times a to the power of minus 1. So a times a to the power of minus 1 going to give us identity. Actually, what is identity mean? uh, if you study in the elementary school, it's going to be, if you see something like that, like x plus x is equal to um, let's say 2x is equal whatever the number is, like 6, and x, so like whatever the number gives x is equal to 1, that's the identity. It means like x times x to the power of minus 1, it means x over x, which is equal to 1. So the same thing right here. Identity means it's almost 1. It's 1 actually. It's actually 1. So it means ix identity x, and b to the power of a minus 1, which mean this is this system is invertible. So therefore, this system has a unique solution. So in case if you say, like, let's say a x1 is equal to a x1 is equal to b. Let's say we have two solutions right here, x1 and x2. So if x1 is equal to b, it will be equal to ax2, which means x1 and x2 are equal. Therefore, this system has a unique solution. That's our proof for this question. So I hope you guys enjoy this video. Have fun. Enjoy your weekends.